Okay, we're in the final section, which is section 39. It's a section on circles. So we'll go to the whiteboard soon, but bottom line is we're going to give a short introduction to graphing circles. And then we'll go to examples. I will go to the whiteboard. We'll cover the stuff that's in the lecture portion of the notes. Won't take long, by the way. But they give you a picture. Hopefully in the picture you realize there's a picture of a circle. It's certainly drawn in the Cartesian plane, X, Y. You should identify, just looking at the picture, that there's a point, a center point. There's a radius drawn here. The radius, there's a point along the circle. And then there's these 4 points over here I want to point out. And what's nice about these 4 points is that they're really easy to come up with. And why is that? We're moving up from the center an equal amount. We're moving, when I say equal amount, it's the radius, moving up, moving down, moving left, moving right. It's super simple to do. All right. The problem for a lot of students, though, is actually finding out what these points are. And we'll certainly go through that. Not only will we do it in lecture, but we'll also do it throughout the examples. All right. So let me go to the whiteboard and let me switch screens. And give me a second to do so. And I got to do this, right? Okay, we're back at the notes, right? But I'm on the whiteboard now. So what I'm going to do is just simply talk about these pictures over here. All right. So this one over here, I want to just claim that, looking at it, and I'll explain what I'm looking at. I'm looking at a circle. I see the circle, and I'm just going to just trace over the circle. Circle looks like this over here. And again, when I draw the circle, certainly by hand, it's not very good. Even though I'm tracing over the circle that's drawn by a machine, it's still not perfect. Hope you realize that. All right, so let's talk about this over here. This is going to be the x-axis, and this will be the y-axis. All right. I notice there's a series of points down. I'm going to go through that with you. First point I want to get is this point right over here. And this is by inspection. This is me looking at the picture. The point there is called the center. Over here, this is the center point. Is the center of the circle that's drawn. What does that center appear to be? 1, -1. All right. And I see other points, and that claim over here, I see this point over here, and I'm looking at it, and I could probably figure out that it looks approximately 2 along the x-axis, but a little bit below 1 on the y-axis. So I'm going to say that might be too tough for me to do. So I'm going to look at this point here. This looks pretty easy. This looks easy. This looks easy. This looks easy. And I'll explain why I believe they're easy. I believe they're easy because it looks like what's happening here is I'm just moving up from the center and moving down from the center. And if that's true, what I know about this, I know what this point is partially. So if I'm moving up from the center, down from the center, the x is not changing. And I think you recall the center was 1 for the x. Now let me look at the other points, these two over here. Again, the claim is I'm moving to the right and I'm moving to the left. What's not changing? The y from the center. Again, I'm moving to the center. What's the y? It's -1. I'll write that down. All right. So then the deal becomes is, can you read from the graph the other values to those points? And I think I can. For example, looking at this thing over here, it looks like the y is 1. Looking at this point over here, whoops, sorry about that. Looking at this point over here, it looks like the value is -3. All right, let's keep going. Looking at this point over here, it looks like the x is 3. And looking at this point over here, it looks like the x is -1. All right, let's go through this and discuss it again. What I'm claiming over here is the center is 1 -1. If you move up, the x doesn't change, it's 1. But if you move up -1, hit 2, I'm going to say it appears that I moved up 2 units. So I'm going to say the radius, looking at my picture, is 2. Let's see if that's true. This point, did I move over 2 units? Well, look at it. It looks like I moved over exactly 2 units. So for example, if we had 1 for the x, I'd be at 3 for the x then. Well, if I'm at 1 for the x here, and I move 2 in the other direction, I'd be at -1. Each point along the circle is exactly 2 units away from that center, which brings us to the equation of the circle. All right, so let's talk about that next. And I'll go through this in detail. I pull this over here. We'll get back to this in a second. All right, I'm gonna arbitrarily put a circle down. It's not a great looking circle, but maybe something like this over here. All right, I'm gonna put a center down, and I'm gonna tell you the center. That's my center there, is a point, and I'm going to arbitrarily call it H, comma, K. And then I'm going to pick a point along the circle. It doesn't matter where I pick the point, but I'm going to pick the point over here. So this can be a point on the circle. It doesn't matter where the point is, but I'm going to call that point X, comma, Y. And now what do I have? I have a distance between the center and that point. All right, what's this thing called? Radius. The abbreviation for the radius, well, use the letter R. All right, so let's write these points down again for you. This point over here is H, comma, K. And this point over here is X, comma, Y. No matter what point I pick on the circle, it's always going to be the same distance R from the center. So I got my distance formula, and something we've done in the past. Let's write that down. So what's the distance? Well, the distances are, let me go back to a different color. Go back to black. The distances are, right? So the distances are, what's it equal to? The square root. Well, we've done distance before. It's going to be X minus H squared, just using the distance formula, Y minus K squared. There's nothing wrong with that, but I want to write it a little bit different. And what I'm going to do is I'm going to square both sides. You get R squared equals X minus H squared plus Y minus K squared. Typically, we try to write the problem a little different than this over here. And what I mean by that, equations are reflective. I like to put the R squared on the right side. So it's going to be X minus H quantity squared plus Y minus K quantity squared equals R squared. This is the equation of a circle in standard form such that the center, and we'll go through examples, is H comma K, and the radius is R. Let me go back to the notes and point out that in the notes we talked about, let me see if I did that. I said, yeah, I'm sorry, I did do that. So we got this over here. We put this down, we put this down. Now let's look at the example. All right, let's look at an example. An example I want to look at is this problem over here. And I'll write this down for you. I'll pull it over. And push this away. Now, I want to claim that if it's written this way, it's nice to have it written this way, but this could be simplified. And someone says, what do you mean simplified? Someone could expand it. And if they did that, what would they get? They'd get X squared minus 6X plus 9 plus Y squared plus 8Y plus 16 is 25. And we expanded it. There's no doubt about it. Now, I'm not going to say that it simplified it, but that's an expansion. X squared plus Y squared. Let's keep going. Minus 6X plus 8Y. Let's see. 9 and 16 is 25. Equals 25. I guess I could take 25 from both sides. And what would you end up with? A pretty simple equation. X squared plus Y squared minus 6X plus 8Y is equal to 0. Now the problem with this form over here, although it may, probably didn't make a mistake, equivalent with this one over here, this one's hard to read. But it is simpler. This one's easy to read. All right, let's go through it. I'm going to push this up. And I'm going to copy it down before I push it up. Let's push this up. Okay. What's the equation of a circle look like? I'll write this next to it. X minus h quantity squared plus y minus k quantity squared equals r squared. With the understanding the center is h comma k and the radius is r. So looking at this over here, it's super simple to pull off the center from it. Let's write the center down. I want to put out the center as HK. So doing that, I hope you realize that if you put H here, it would make this thing 0. So what number would make this 0? 3. Write that down for you. It's equal. All right, let's take a look at the next thing. If you took the K, you put it here, and make it 0. So what number would make this 0? Would be minus 4. And then what's the radius? R. R is, well, what square gives you 25 is 5. So I'm going to claim that, as a minimum, I know the center and radius of this. I'm going to draw a picture of a circle. Again, not the best looking circle in the world, but that's my circle. I'll put my center down, and then I can put 4 points along this. We'll use graph paper later. What's my center? Let's write this down. It's 3, comma, minus 4. I can write these points down now, at least partially anyway. There's 4 of them. And let's see, 3, 3. Let me tell you why that is. I'm just moving up and down, so the 3 is not changing. And now I'm moving left and right, so the minus 4 is not changing. Okay, this is where some students are going to struggle. I'm certainly, struggle's okay, but we want you to get it. It isn't like this is magic or something. But I need to, from the minus 4, this is moving in this direction of the y's. I need to move up 5. And if you're at minus 4, move up 5, you'd be at the number 1. All right, let's keep going. If you're at minus 4, this is along the y's now, moving up and down, and you move down 5 units, you'd be at minus 9. All right, let's keep going. Again, we'll use graph paper later. So I'm going to move left and right now. And what's changed moving left and right? The x's. So if you're at 3 and you move right 5, you'd be at 8. If you're at 3 and you move to the left 5, you'd be at minus 2. It's a very simple arithmetic problem. Now, when I say that, do mistakes happen? Of course they do. All right. So I can say, for the most part, it's not bad. We can do that. All right. So I'm going to go to the next page. And I want to just grab this momentarily. I'll just do these points here. I'll grab this. Let me just copy it. And let me go back. And I'm going to paste it. It's over here. I'm going to blow this up. And we'll see how I did. Did I get what they said I should get? And let's go through it one at a time. And you should be doing this too when you do homework. So 3 minus 9, 3, 1, minus 2 minus 4, and 8 minus 4. I will go to graph paper later, by the way, but right now you should have some sense of what I did. I got the center and I got the radius. All right, go back to the next page. And this is where, a lot of students look at this and say, I don't know what you want me to do with this problem over here. I'm going to pull it on the side. And I want to tell you that the way the problems are expressed on exams, they kind of lead the witness. They tell you what it is. Someone says, what do you mean they tell me what it is? They actually will say, find the standard form of the equation of this circle and identify the center and radius of it, and then graph it. Well, I'm going to tell you right from the get-go that this thing is a circle. So what I want to do is I want to get in that standard form, and I'll write that down for you. The standard form is going to look like this: x minus h squared plus y minus k squared is equal to r squared. So the first thing I got to realize is that it has something to do with perfect squares. I mean, they're all over the place. So what I'm going to do is I'm just going to collect my terms, like the x terms first. The reason being I see that here. So x squared plus 10x. Then I'm going to collect my y terms, plus y squared minus 6y. I want to tell you what I did. I collected the x's, I collected the y's, and I'm going to get the number on the other side. And how do I do that? I'm going to subtract 25 from both sides. Okay, I'm still not there. So someone says, what are you trying to do? Well, I need to go back to my past and I need to get perfect squares. How would you do that? By completing the square. So hopefully you remember back when we did completing the square, well, the coefficient here has to be 1, and it is. This is nice if it's even, and it is. We take half of this number, which is 5, and we square it. So if you square the 5, what would you get? Plus 25. We're completing the square. Now remember, if you add 25 to the left, you must add 25 to the right. Let's keep going. And again, I want to point this out. The coefficient on the y squared term is 1. This is good. I can take half of that pretty easily, right? It's minus 3. And when you square it, what do you get? Plus 9. I need to add 9 to both sides. Again, we're going to go through other examples, but right now, I think I have perfect squares all over the place. Let's do one at a time. What's the first guy? X plus 5 squared plus, well, the second guy is also a perfect square. What do you get over there? Y minus 3 squared. And what do you get on the right side? 9. So I can write down the center. And the center is, well, I want to point this out to you. What makes this thing 0 is minus 5. I'm going to point this out to you. What makes this 0 would be 3. And what's the radius? Well, again, you have to say stuff. What squared would give you 9? And that would be 3. All right, I'm going to use graph paper later, but right now I just want to go through, a really primitive thing without using graph paper. Draw my circle. Yeah, it looks pretty awful. I'm going to put my center down here and then put down 4 points. What do I believe the center is? Minus 5, 3. What am I going to do? Move up, move down, move left, move right. That's all I'm going to do. Let's put these points down for you. This is a 4-point technique, and that's typically what you want to be able to do. So if I move up and down, the x is not changing. If I move left and right, the y is not changing. All right, here comes the tough part. And students do struggle with this. The radius is 3, which means I have to move up 3, down 3, right 3, left 3. All right. So what's changing over here? The y's are changing. If you're at 3 and move up 3, you'd be at the number 6. Okay, let's keep going. If you're at 3 and move down 3, you're at 0. And again, if that takes your time to think through that, take your time to think through that. All right, let's keep going. Now we're here and we're going to move to the right 3 units. So if you're at minus 5 and you move to the right 3 units, you'd be at minus 2. I'll use graph paper later. If you're at minus 5 and you move to the right 3 units, you'd be at minus 8. Now, again, the question is, do you make mistakes? Of course I do. And what I want to claim over here is, I just want to look at the, if I got the points right, and I'm going to use graph paper later. All right. So let's see if we got the points right. So I'm going to look at this. Did I get 3 minus 9? I'm sorry, I'm in the wrong place. I'm over here. Let me get my eraser out. Sorry about that. Let me get my pen, see if I got it right. Did I get -50? I see it right here. Did I get -56? I see that right there. Did I get -83? I see that right there. Did I get -23? I got that there. I got all these things. I also want to point out, did I get this, which is standard form? And I got it. Okay. I want to go to the next page and I'm going to grab a piece of graph paper for you. And you should learn how to use graph paper. And the back page. And I want to do this problem again. Just give me a second. This over here. Take that graph paper and start to blow it up. And I really going to emphasize that having graph paper can, in fact, be helpful. All right. So what's the first thing I want to put down? I want to put the center down. Now, certainly requires some counting, but it's not a lot of counting. So what's going to be, 5 left and then 3 down. And let me see if I can do that. And I got to get my pen out, right? So I'm going to go 5 left and 3 down. 1, 2, 3, 4, 5, and then 3 down. All right. So I got the center down. Now what I'm going to do is I'm just going to count from that position 3 units up, 3 units down, 3 units left, 3 units right. Oh, I made a mistake there. I did it again. I'm going dizzy. It's pretty good, right? And then what I'm going to do, I'm going to draw a circle through that. All right, I'm going to go this, and I'm going to put these points down now for you. And again, I'm looking at it. I can make mistakes. I'm not saying I can't. So what do I got over there? These count 1, 2, 3. Oh, -5. 0. What's this point over here? Let me count it. -5. And then got to count down 1, 2, 3, 4, 5, 6, 7. Let's see. 1, 2, 3, 4, 5, 6, -6. Let's do this point here. Again, look at my picture. Looks like -2. And then let me count down. 1, 2, 3, -3. This point over here. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 to the left. And then 3 down. And someone says, we're getting the same points. And let's take a look at this. You know what? I did something wrong there. I got to erase it. I just realized it. I put the wrong center down. I got the whole thing messed up, right? So let me erase. Someone says, how do you realize you make mistakes so quickly? I slipped the other graph. It was all wrong. All right. I'm sorry about that. So -5, 3. Let me go back to my picture. And -5, 3. I'll do this over here. 1, 2, 3, 4, 5, and then 3 up. All right. Let me go back up here. Radius of 3. And I apologize for that. Put this here. Radius of 3. I'm just counting up 3 units. 3 units to the right. 3 units to the left. And you get, by the way, when you're doing homework, you can make mistakes. It happens all the time. Sometimes it's just simply you read something wrong or you copy something wrong. It happens all the time. And what you do is go look back at the key. And I'll look at the key again as well. So I'll put these, draw my circle in, right? Sort of. That's good enough. So let's put our points down. I'll put this point over here. What's that going to be? I'm just going to count 1, 2, 3, 4, 5. And then it looks like 5. I'm sorry, -5 and 6 up. What's this point over here? -5, 0. What's this point over here? It looks like -2, 3. And what's this point over here? Let's take a look. Looks like -8, just counting. And then it looks like what? Let me get my eraser out. -8, looks like 3, doesn't it? All right, nice to have graph paper. Let's see how we did. Let's see if we got these points over here. -5, 6, yeah. -5, 0, -2, 3, and -8, 3. So graph paper can be helpful, particularly to students that have trouble with arithmetic. You can counter the points. What's the problem with graph paper? Well, a lot of times if it's really small, let me show you what I mean by that. You can't see the grid. And certainly you can blow the paper up if you like. Using electronic devices, you can blow it up as much as you like. You can really blow this up a lot. It's going to scale nicely and not get grainy. You could also print it out on a printer if you have a printer. All right. Okay. Thank you. And I think we're done with that. And now we need to go to the examples. As we start doing examples, hopefully the stuff that's been talked about becomes more concrete for you. Thank you for listening.